This is Math Analysis, Chapter 9, Section 2, Polar Graphs. I'm your host, Dr. D. That's my stage name. Okay. Let's get going here. So in Section 1, we did really simple graphs like theta equals pi over 4. And that became just a straight line going up toward pi over 4 and back away from pi over 4, just a straight line. Or a function like r equals 2. So that would be a circle at radius 2. Or, if we want to get really complicated, r equals negative 2. That would be a circle at r equals negative 2. It would be like an inside-out circle. Okay, so today, though, we're going to get a little more complicated, and we're going to graph things like r equals sine theta, r equals cosine theta, r equals 5 plus 3 cosine 2 theta, all kinds of fun stuff. So, we'll start with r equals cosine theta. Now in the book, they start with r equals sine theta. You can take a look at that to get a little more example of what's going on here. But what we're going to do is we're going to expand our scale. So instead of each circle being 1 unit, we're going to make each circle 0.25 units. So 1 unit is out to here. Okay. Now, in any graph, what you're going to do is pick x's, find y's. Well, same thing here. We're going to pick thetas and find r's. So if we pick theta equals 0, then cosine of 0 is 1. So r is 1. So there's our first point there at r radius 1, theta 0. Now, if I take 30 degrees, then I have, oh no. Now you know what, we're just going to do this in red. We're just going to do it in red because I like it in red. So, cosine 30 degrees is square root of 3 over 2, which is about 0.86. So we go with 30 degrees and 0.86. So there's 0.5, there's 0.75, 0.86 would be right about there. Okay, then we go to 45 degrees. Cosine 45 is square root of 2 over 2, which is 0.707. So there we are at 45. There's 0.5, 0.7 would be right about there. No, I'm sorry. Wait, that's not 0.7. Cut to 2. This is 0.5, so this is 0.75. So 0.7 would be right there. Okay, then we go to 60 degrees. Cosine 60 is 1/2. No estimating required here, so we go 60 degrees, bam, 1/2 right there. And then we go to 90 degrees. Cosine of 90 is going to be 0. So I'm back down to here. All right, so at this point, we have a beautiful semicircle. So let's continue on. So if we've just gone from 0 to 90, well, let's go to 120. Cosine of 120 is 1/2, negative 1/2, I mean. Well, where is 1/2 at 120? Well, here's my 120 up this way, but if I'm going negative 1/2, that means I'm coming back down this way. Oh, rats. Cosine, 120 is this way. So 1/2 is down here. That's negative 1/2 at 120. See, here's the 120 degree angle right there. Negative 1/2 is this direction. Now, if I go to 150, cosine 150 is square root of 3 over 2, negative square root of 3 over 2, so it's negative 0.86. Negative 0.87, actually. So at 150, we're going this way. But remember, we're going away from that. So we're going 0.5, 0.75, 0.86 would be right about there. Okay, now if I want to get some points in between there, yeah, let's do that. Let's get 135. That probably would have been better to get the 135. Cosine of 135 is negative square root of 3 over, or negative square root of 2 over 2. So we've got negative 0.71. So there's my 135 right here. So if I go negative 0.71 this way, then I'm going 0.5, there's 0.75. So you can see what's going to happen here. We've got our what the heck happened? 0.5. Okay, it's going to end up being yeah, this will end up being a circle that looks like this. So now, if that doesn't look like a perfect circle, it's the camera's fault, once again. Okay, now, this is r equals cosine theta. If you look in the book, you can see r equals sine theta is also a circle, but instead of being in the first and fourth quadrants, it's in the first and second quadrants. Okay, now, let's get a little bit more interesting. We're going to crank up the juice just a little bit. Let's try r equals 3 cosine 2 theta. All right. R equals 3 cosine 2 theta. Same thing now. We're going to pick thetas, find r's. Now, the problem is, if I pick thetas like, let's say, well, let's take our first theta as 0. So cosine of 0 is 1, 3 times 1 is 3. So, you know what, let's change our scale back. We'll make our scale 1 now, so there's the point 3, 0. Okay, now, if I take theta of 30 degrees, I'm going 2 times 30 degrees, which makes it 60. I'm skipping a couple of points. So let's make theta 15 degrees, and now I've got 2 times 15 is 30. Cosine of 30 is square root of 3 over 2. So now it's time for our trusty calculator. So I go, square root of 3 over 2 is about 0.866, and I multiply that by 3, and I get 2.598. So 2.6 at 15 degrees. So 1, 2.6, bam, right there. Then I'm going to try 30 degrees. So now I've got cosine of 60, which is a half. 3 times a half is 1.5. So at 30 degrees, we're at 1.5. Now, if we go 45 degrees, 2 times 45 is 90, and cosine of 90 is 0. So now I've got the curve that looks like that. actually more like this. Okay, so we should just keep going. So if I go 60 degrees, now 2 times 60 is 120. Cosine of 120 is negative square root of 3 over 2. Oh no, I'm sorry. 120. Cosine of 120 is negative a half. So negative a half is negative half times 3 is negative 1.5. So at 60 degrees, we're at negative 1.5. So 1.5 away from the 60 degree direction. Okay, so now we go to, well, let's go 75 degrees, and 2 times 75 is 150. Cosine of 150 is negative square root of 3 over 2, I guarantee it. Now we multiply that puppy by 3, and we get negative 2.6. And so negative 2.6 at 75 degrees is 2.6. Bam. Then we go 90 degrees. Well, 2 times 90 is 180. Cosine of 180 is negative 1. 3 times negative 1 is negative 3. So 90 degrees, we're at negative 3. Okay, so now we've got the curve that looks like this. Okay, looking kind of strange, but we're on target. So next, I'm going to try 105. 2 times 105, 110. Cosine of 110 is square root of 3 over 2, negative square root of 3 over 2 times 3. Basically what we're going to see is it's going to go like this. Then it's going to go like this. Then it's going to go like this. Then it's going to go like this. So this is our full curve, r equals 3 cosine 2 theta. How did he know that? I'm a wizard. Actually, here's how I know that. Because this is called a classic curve. And if I know the basic shape of the classic curves, then all I have to do is graph a couple of points. I've got the whole curve. So check out page 563 in the book. So you notice that r equals 3 sine 2 theta is a shape similar to this, only here the petals are on the x and y axes, but 3 sine 2 theta, the petals are right in the middle of each quadrant. So it's basically rotated 45 degrees. All right, everybody get to page 564 now. We see a list of classical curves. Okay, so first curve is the rose. Here is the rose. Doesn't look like a rose. Looks more like a daisy to me, or a sunflower. But they didn't listen to me when I told them to name it that several thousand years ago. But this is a rose. Now, what makes a rose? It's going to be some number, r equals some number times either sine or cosine, some number times theta. Now, what does the, in r equals a cosine n theta or r equals a sine n theta, the a is the radius of my flower. So the distance from center to each tip of each petal is going to be 3. Now what's the 2 mean? The 2 is the number of petals. So if the n number here is even, then it's always going to be 2 times that number. So notice we have a 2 here, so that means we're going to have 4. If I had 3 cosine 4 theta, then we would have 8 petals. 3 cosine 8 theta would give me 16 petals. Now, if the n here is odd, then that's exactly the number of petals. So 3 cosine 3 theta would give me 3 petals. 3 cosine 5 theta would give me 5 petals, and so on. So odd number here gives you that number of petals. Even number here gives you twice as many petals. This number is the radius of each petal, or the length of each petal, the radius of the flower. So the next classical curve is going to be the lemniscate. Now, that's like an airplane propeller, and the equation is going to look like r squared equals a squared times either sine or cosine of 2 theta. So when you see that equation, you know you're looking at that shape. The third type of classic curve, we're going to go to the cardioid. The cardioid is r equals a plus a cosine theta, or a plus a sine theta. Now, notice it's in the shape of a heart, basically. Not a heart like Valentine's Day heart, but a heart like an actual heart, like an actual organ in somebody's body. So notice the a's have to be the same. If those two numbers are the same, so it would be like r equals 3 cosine 3, 3 plus 3 cosine theta, or r equals 5 plus 5 sine theta. Those are cardioids. Now, if we change the number, so r equals a plus b cosine theta, or r equals a plus b sine theta, then we don't have a cardioid anymore, we have a limaçon. It's a French word, could injure your throat trying to say it, so be careful. A limaçon. So those puppies are similar to the cardioid, only they have a little loop inside it. So it's almost like an apple with a worm that's crawled inside. So the last type of classical curve is the spiral of Archimedes. And that's basically r equals a theta. So the spiral of Archimedes, let's just take the simplest spiral, r equals theta. And we'll go in terms of theta in radians. So when theta is 0, r is 0. When theta is pi over 6, r is about 0.52. When theta is pi over 4, theta is about 0.79. When theta is pi over 3, r is 1.05. When theta is, where are we here, pi over, we'll skip to pi over 2. Theta is pi over 2, we've got 1.57. Theta becomes pi, and that's 3.14. Theta becomes, let's just jump to 3 pi over 2, so that's 4.57. Something's wrong with that. Let's see. I gotta check that out. Wait, just screwed up. 4.71. Okay. I knew it had a 4 and a 7 in it, but I screwed up. 4.71. All right, now let's jump all the way to 2 pi, and it's going to be 6.28. All right, so what's that puppy look like? 0, 0. 0.5 at pi over 6. So there's 0.5 at pi over 6. Then 0.79 at pi over 4. Then 1.03, or 1.05 at pi over 3. Then 1.57 at pi over 2. And then 123.14 at pi. And then 4.71 at 3 pi over 2. And then 6.28, bam. So what's this puppy going to look like? Nice. Okay, so notice the further this moves around, the further away it gets from the origin, because r equals theta means that as theta increases, then the radius increases. And this goes forever and ever. Hallelujah. Okay, now, I would advise that you memorize these 5 classic curves. Now, there are 2 good reasons for that. One, because when you're graphing them, notice when I was doing the cosine 2 theta curve, all I had to do is really graph 1/2 of one petal, and I knew all the rest of the petals. So if you know the basic shape, then you don't have to graph that much. All you have to do is get a couple of points there, and then you realize where the whole thing goes. The other good reason for memorizing these 5 classic curves is that sometime you might come in here and there could be a quiz! So, you want to be ready for that. Okay, that's it. Have fun with these.